for Physics 2212 Lab 1. And this is about two interacting U-tapes, and the first thing I had to do was write down my expectations for how they would react. I predicted they would repel each other since they have the same charge, and I was correct about this. And then I had to see how one U-tape would react with the book, and it was attracted to the book the same way it was attracted to my hand. Next, I had to see if the U-tape was positively or negatively charged, and by rubbing my hair with a pen, I could negatively charge the pen, hold that pen close to the U-tape, and the U-tape was attracted to the pen, therefore the U-tape is positively charged. Now I had to do this experiment where I set up two books, put the tape B between the books, and then put tape A right here, and then on tape B there are two forces acting on it, which is the force due to gravity and the electric force from tape A. And we can conclude that the net Y component of the force of tape B is 0, since the momentum of tape B isn't changing, because once you hold tape A here, tape B won't move anymore. And in order to determine the gravitational force on tape B, I need the mass of the floating part of tape B, so I can take the width of tape B, multiply that by the length of tape B, excluding the tab, and then subtract the pieces of tape B that are on top of the books, because the tape has to be attached somewhere. And then get the area, convert the area to meters, and then multiply that by the mass of clear tape, which is 1 gram per meter, and then I get 0.475 grams as the mass of the floating part of tape B. Then there are some assumptions that we do need to make, like that we have to assume that each U-tape has the same net charge, which we must do since each atom on tape A is interacting with each atom on tape B, and if tape A and tape B have the same charge, we can use tape B's charge to find its own electric field from there, and we use this to help find the number of atoms and the number of electrons excess or deficient on tape B. And then we need to find the force due to gravity on tape B, which we can find to be 4.655 newtons, and the distance between each tape in this part of the experiment is only 2 centimeters as I observed, and then we can set the forces equal to each other to find that the charge on tape B will be 4.5485 times 10 to the negative 6 coulombs, and we can set this charge of tape B equal to the charge of a proton times the number of electrons missing, and we set this to the charge of a proton because it's, missing electrons, and also since this is positively charged, it'll be a positive charge instead of a negative charge because we have a deficiency of electrons. So we can divide the charge of tape B by the charge of a proton to get that there are 2.839 times 10 to the 13th electrons missing. From here, we know that, we need to find what fraction of atoms gave up electrons. And earlier, we are able to do all of this because of our two assumptions that each U-tape has the same net charge, and we must, I need to stress the importance of this, treat each tape as if all of its charge were located at a single point, because this allows us to use the formula for the point charge, and this helps us calculate these values by setting the forces equal to each other. Which otherwise, if we didn't do that, then we would have to deal with some more human error because of misalignment. And in order to find the fraction of atoms that gave up electrons, we get the length of an atom, and use that to find the area of an atom, divide that by, or the area of the tape by the area of an atom to get that there are 4.75 times 10 to the 19th atoms on the sticky surface of the tape. And then we can find the ratio of the number of deficient electrons to atoms by dividing the number of deficient electrons by the number of atoms, and then we get 5.9774 times 10 to the negative 7, or for every missing electron, there are 5.9774 times 10 to the 7th atoms. We made the assumption that the length of the atom is 1 times 10 to the negative 10th meters, that each U-tape has the same net charge, and treating them as point charges. And for the experiment, the length of the tape B was 25.6 centimeters, the mass of tape B was 0.475 grams, the distance between the two tapes was 2 centimeters, the force due to gravity and the electric force were both 4.655 newtons on tape B. Well, this was the gravitational force on tape B, this is the electric force on tape B. And what if electrons had positive charge and protons had negative charge? Well, not much would really change, because if you think about it, positive and negative still attract, so really it would be more so switching of labels, although it would be the protons that gave off the negative charge instead of the positive charge. But either way, the net result would still be the same. And it's important to handle the charged tapes as little as possible, because when charged tape comes in contact with hands or other objects, it loses some charge when they touch. So we have to touch it as little as possible before the experiment to avoid this. And for the coding part of the lab, I had to create some code to find the magnitude of the charge on one piece of tape. And I'm running out of time, so here is my code. And this I just did a little bit extra without realizing it, but I don't actually need any of this. And then here's the results. The magnitude of the force of gravity is 4.655 newtons. The position of tape B relative to tape A is 2 centimeters in the y direction. The magnitude of the charge on each piece of tape in coulombs is 4.5485 times 10 to the negative 6, which is the exact same as I had earlier. And this blue arrow here is the force, represents the force of gravity. The red arrow represents the electric force from tape A. And thank you very much.